Today's lesson's over permutations and combinations when it comes to probabilities. And so for our vocab, we have 3 vocab words. A factorial is the product of all positive numbers less than or equal to the given positive one. So here we have 4 factorial. That's what the exclamation is for. It's representing 4 times 3 times 2 times 1. So you always start with that first number and multiply all the numbers that are positive all the way down to 1. And so we use factorials in permutations and combinations. Permutations is the arrangement of objects where the order matters. Combinations is when we arrange objects where the order doesn't matter. So if I cared who got in what place, then permutations is what I wanted. If I was picking people for my team, it didn't matter who I picked when, basically. So those are kind of 2 examples here. So example 1, Taisha and Liam sign up for an open mic night with 32 available slots that are filled at random. What is the probability that Taisha will perform first and Liam will perform second? So if I'm setting up my probability, I want to first figure out how many total possibilities I have, or outcomes I have. And so since there's 32 slots, and let's assume that everybody has filled it up, then that means that there's 32 ways to pick the first person, 31 to pick the next one, 30 to pick the next, and so on and so forth. And so that's representing factorials. And so it's just a fast way of writing all the different combinations without having to write them all out, basically. And so here I can write 32 factorial for my total for everybody. For our purposes, Taisha and Liam need to go first and second. So there's one way of picking Ty, there's one way of picking Liam, but then there's 30 factorial for everybody else. And so from here, I can do some simplifying so I don't have to do a bunch of number crunching. And so 32 factorial, you can rewrite it as like mapping it out. So 32 times 31 times 30 factorial. And then the 30 factorial on the top and the bottom cross each other out, leaving you with just 1 times 1, which is 1 on the top, and then 32 times 31 on the bottom, which I believe is 960. So our probability is 1 out of 960 people, or probability. So for example 2, for a project, Rami selects 12 family photographs that will play randomly in a slideshow. Slideshow will not repeat photos until all 12 have been shown. So he has 3 of his family, 2 of his brother, 3 are just him, and 4 of his sister. What are the probability of the first 4 being of his sister? And so total, there's 12 pictures. So then 12 factorial should be everyone or all the pictures. So there's 12 ways of picking the first, 11 of the next, 10, so on and so forth. So if I'm looking to choose Rami's first, there's 4 ways of doing that. And then there's 3, and then there's 2, and there's 1 for the first 4. But then I need the rest of them for the slideshow. So then there's 8 different ways, or 8 factorial ways of picking the next 8 slots. And so then I have this where I need to simplify. And so I can do the 12 times 11 times 10 times 9 times 8 factorial. And so I usually go down to the highest factorial on the top. And so then I'm able to simplify and make it a little easier. So I'll multiply 12 times 11 times 10 times 9 and 4 times 3 times 2 times 1 on the top. On the top, that gets us 24. And then at the bottom, multiplying all those out gets us, I believe, 11,880. And then that would be our probability. Remember, all of these we could simplify, but there's really no need to for our purposes. So example 3 says one game show has contestants arrange 5 number tiles to build their guess at the price of the prize. Mishka is given 5 tiles with 2, 2, 5, 5, and 8 on them. She needs to arrange the tiles, or if she arranges them randomly, what is the probability that she arranges them correctly for the price that's $25,852? So since there's 5 tiles, there's 5 ways of choosing the first, 4 of the second, 3 of the next, and so on and so forth. So if she was going to do it right, she would pick 2, or there's 2 2s for the first one, so she could pick one of those possibilities because either one would work. And then there's 2 ways of picking the 5, or the first 5, because there's 2 available. There's only 1 way of picking that middle 8. And then there's 1 way of picking the last 5, and there's 1 way of picking the last 2. So then I will have 2 times 1 for the 2 factorial times 2 times 1 times 1 times 1. So that'll really get me 4. So there's 4 ways of doing the top part. So not a lot of ways of doing it right. But then there's 5 times 4 times 3 times 2 times 1 factorial. So that gets me 120. So 4 out of 120. And the last example, I have 3 points randomly chosen from those named pentagon A, C, E, G, J. What is the probability that they all lie on the same line segment? And so here I have 3 points on the same side. Now for this pentagon, I have 10 points that I could choose from, so there's 10 ways of doing it just randomly. So 10 factorial. But on top, the first one, since it doesn't matter which point you start with, they all need to end up being the same line. There's 10 ways of choosing the first one, because it doesn't matter if I pick A or F. It didn't say what specific line segment they had to be on, so I can say 10. But after you choose the 10, then for them to be on the same line segment, there's only 2 other ones. So like if I pick A, I need to pick one of the other 2 possibilities, and then that forces me to be 1 less. So then it's 10 times 2 times 1. And so that would get you 20 on the top. Okay, but then here you could reduce it a little bit because 10 factorial. I can make it 10 times 9 factorial, so I can get those 10s to cancel out. And from there, I need to multiply my 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 to get my final value of 362,880. And so it should be 2 out of 362,880 for my probability. Okay? Remember, if you have questions, remember to email me. I'm sorry that I'm gone. I had to take a child to the doctor today, so unfortunately I will not be there to go over this with you. But I will see you all on Wednesday. Bye.